Now we look at vectors in a coordinate system. So I've brought vector v and vector w over, and I've just put them on a regular xy plane. I've also noted their initial points and their terminal points, as you see there. It can be helpful for us to have our vectors with the initial point at the origin. So that would be in standard position. Well, notice when we do that, we have in vector w, the initial point is at 0, 0. That's what it means to be in standard position. And the terminal point is at -3, 1, 2, 3, 4, 5. Well, if you'll notice, if we did -7 minus -4, we would get -3. If we did 6 minus 1, we would get 5. So it's very easy to translate things that are not in standard position into standard position. Let's try it with vector v. According to what we just saw over here with vector w, we should be able to do 9 minus 5 and get 4, 3 minus 2 and get 1. We think that when we move this into standard position with its initial point at the origin, it should terminate at the point 4, 1. Let's see if it does. When we move this, we'll do a quick check. Yes, this terminates at the ordered pair 4, 1. When a vector is in standard position, we can name it by its terminal point. So vector w could be named -3, 5. Instead of parentheses, which would indicate we have an ordered pair, we use these symbols to indicate we are dealing with a vector. So if we wanted to represent vector v, we could say that has a terminal point at 4, 1 when graphed in standard position. Now let's take a look at adding these two vectors. And we're going to do v plus w. Notice what happens when I know their names in standard position. If I move vector w to the end of vector v, as we have seen, and draw its resultant vector, we notice that it has an initial point at the origin, which it always will if we're dealing with a vector that starts in standard position. Here's the resultant. Notice the end point of the resultant is at the ordered pair 1, 1, 2, 3, 4, 5, 6. So we could name that resultant as 1, 6. Notice again, if I add vector v plus vector w, 4 plus -3 is 1, 1 plus 5 is 6. So it's very easy to add vectors when they are in standard position. Okay, here is a nice summary of that. We're going to look through a couple of examples. If vector v is the vector 1, 4, and vector w is the vector 3, -2, find v plus w. Well, that would be 1 plus 3 and 4 plus -2. So it would be the vector 4, 2, which means when we graph, if we were to graph this and do this graphically, the sum, the resultant, would start at 0, 0 and end at 4, 2. For v minus w, we will do 1 minus 3 and 4 minus -2. The resultant vector would start at 0, 0 and end at -2, 6. In this next example, we have vectors r and s. R is the vector that starts at 0, 0 and ends at -3, 8. S starts at 0, 0 and ends at 2, -5. If we're asked to find 5r, that means we are multiplying by that scalar. It's going to be 5 times -3 and 5 times 8. Both of the components of the vector. Each of those parts is called a component. So we have the vector -15, 40. And then we can combine scalar multiples with addition and subtraction. So we have 2 times r, so let's go ahead and do that. That's going to be negative 6, 16, minus 3 times vector s, that's going to be 6, negative 15. And when we subtract these, negative 6 minus 6 would be negative 12. And 16 minus negative 15 is 31. So that vector would start at 0, 0 and terminate at negative 12, 31.